nanofibers along with electrospinning technology. And today we will be giving you information for biomedical applications of nanofibers and our hybrid electrospinning technology. So first, we would like to show you a presentation and then give you brief information. Afterwards, we will show you some sort of videos which you can see Innovenso's machineries, and you can see what kind of biomedical applications of nanofibers we can produce with our machines. So we can just have our presentation. Okay, so first we will begin with giving you information, what is the nanofibers? So before that, I just wanted to mention and give you the summary of our program. First, we will talk about the nanofibers and give you information, and then we will discuss with you about process of electrospinning and electrospraying. Later on, we will be giving you information about nanofibers in biomedical field. At the end, we will talk about market analysis, and then of course you are always welcome to ask us questions at the end of the webinar. My name is Bushra and I'm working as an international sales specialist at Innovenso.
And my name is Umar. I'm the customer support engineer here at Innovenso.
Yeah, so we can begin our program.
Okay, so let's go back to the first slide. A little behind that, yeah. One more behind.
Yeah, one more. Yes.
Yeah, so electrospun nanofibers. So when we're talking about electrospinning, we're talking about materials that are made in terms of long cylindrical bodies. So you can see a comparison here on the slide, how it compares to the human hair. It's very, very small. So strictly speaking, the definition of electrospun nanofiber would be a fiber with a diameter of less than 1 micron, which is defined as a nanofiber. So let's move on to the next slide. So why nanofibers are so key in research space today, why they're given so much traction, is because they have very intricate properties that attract a lot of attention. So for example, small diameters, so this is like from the range 10 to 200 nanometers. This basically gives a lot of a condition of high surface area and high porosity, which allows the nanofiber scaffolds to have a lot of active sites and allow a lot of processes happening. And finally, they're flexible, which is very important for biomedical space today. Let's move on to the next slide.
So right now we have applications of nanofibers table, as you can see. We can just go
at the previous slide.
Previous slide, please. Okay, so you will see from the table that you will actually find application areas from energy to healthcare and then water and environment. For today's program, we will focus on healthcare. So you see that we have 4 main areas: tissue engineering, wound dressing, drug and delivery, and of course, biological sensing. We can go to next slide, please. And then for the tissue engineering, I'll just give, of course, brief information. But before we come to that, we would like to give you what is the difference between electrospinning and electrospinning process.
Right. So electrospinning and spraying are essentially sister processes. They're the same thing. The only difference is what's the outcome, the end outcome, which is either you get nanoparticles at the end of it, or the end product being nanofibers. But essentially, they're the same thing. They require a syringe pump, they require high voltage, and they require a collector where they deposit onto. So let's move on to the next slide. So yeah, this is just a small like a visual representation of how it looks like. You can see where we extracted it from. Nanofiber, like it's the same air, like where it's coming out of, deposition, where it's depositing out of. Just you see that on the top, they're like fiber strands extenuating, and below you see these particles rupturing into snaps, like snapping into particles. You can see the corresponding SEM images and how they look like, but essentially the processes are the same. So let's move on.
As I have previously mentioned, we have 4 main application areas. First of all, the tissue engineering. The second one, wound healing applications. Third one, drug delivery applications. And lastly, we have artificial blood vessels. For the tissue engineering applications, there are nanofiber scaffolds actually simulate the extracellular matrix, which means they behave very similar to the biological tissues, making them suitable candidates for research and tissue engineering applications. For the wound healing, we have biopolymeric nanofibers, which can be used then as thin patch for wound dressing as they stimulate the ECM. They have antibacterial properties and they are non-toxic. For artificial blood vessel, tubular structures of nanofibers can be used as a vessel, much like the ones in our bodies. And then lastly, we have drug delivery. Due to their degree of porosity, nanofibers have active sites allowing reactions to the catalyze and have chemical releases. Of course, we will give you more information in upcoming slides.
Right. So let's move on to the next slide. Right. So this is like a little bit more advanced. You can see how nanofibers are like in the research space, how they circulate and how work is being done on them. So you can, the diagram on the left shows basically the cycle of it. But essentially, bone tissue regeneration, cartilage tissue regeneration, and muscle tissue regeneration, all of these essentially, therefore, cell culture and then nanofibers having the compatibility to like work with them to see the implants and see the end outcome. They're very, very useful in this regard. So they're like many, like you can see the whole list. There are many research upon materials they're being used. So let's move on to the next slide. Right. So I'm gonna talk about like some of the stuff that we worked on. Like, so one important thing is that nanofibers can be made into vascular grafts. Now these are essentially tubes made of nanofibers, and as my colleague mentioned, they have a unique property called like basically they replicate the extracellular matrix. So what that means is the ECM. That is, it means that nanofibers themselves, the materials, they simulate, or rather they behave very similar to biological material like tissues, so which makes them compatible for use for applications in the area. So when we come to vascular grafts, you can see on the picture, this was made with our nano spinner NS24. It's a tubular structure. The applications right now, they're trying to, it's heavily researched upon, but one example would be dialysis, or other one would be specific for post treatment or for these bloods that are moving. So this is something that we generally use. We have produced something similarly.
So we would like to show it to you because we have it in our hands right now.
So yeah, you can see here, if I'm careful enough, I can show you right here. This was produced about with our nano spinner NS24. We used a special collector.
We can just actually get it closer to the camera. Where is the first camera? Is there the upper? Okay. Right. So here is
here
the vascular graft.
So essentially, it's made with a special collector that comes with that comes as a special design modification for the NS24. It's essentially spun onto a very thin collector, and it comes out as what you see, as I showed you earlier, and in the picture there. So let's move on to the next slide. Just the one before that. Let's go back. Yeah, so I just wanted to show you a table that I extracted from the internet, talking about the polymers that are being electrospun and what type of graft or what type of application they're trying to be catered towards. So you have collagen, which is a biopolymer that people are trying to electrospin for the arteries, and also collagen type 1 for the veins. And then you have you have composites materials like PCl and collagen for the artery. So a lot of research are being specifically done on them. So the research seems highly promising. So let's move on to the next one. So yeah, let's talk about drug delivery applications. So generally, as my colleague mentioned, nanofibers with their porosity, they have this special mechanism in which you can incorporate some drugs like nanoparticles, like embed them into the nanofibers. And this would allow them to have a controlled release. So you would want to have them to be burst released out of the nanofibers. They can be slow delivery or targeted delivery, but the main purpose of it is to transport the drug to a designated target. So let's move on to the next slide. We can talk about our experience in drug delivery. So we had a customer from South Korea where we developed an R&D project with them. but due to NDA restrictions, we cannot. We have to exercise some discretion. But essentially, what we did was we produced a nanofiber product with a particular biopolymer with the drug release mechanism of salicylic acid for medicinal properties, for medicinal purposes. And we were able to successfully complete that project, and you can see the end result written in the last sentence there. So let's move on. Yeah, another very famous application for nanofibers in the biomedical space is wound healing applications. So as we mentioned, they're very similar. They simulate ECM, so they can be latched onto skin, on damaged skin, with specific drugs to allow them to basically activate, or rather accelerate, some healing processes. As you can see in the dermal diagram here, it shows all of it, and I want to show you basically what we produced of it. Like, it's right here. This is the scaffold, PCL scaffold. This is, I believe, medical grade that we produced right here. So it's basically a nanofiber scaffold that we produced onto the aluminum. So this is the purpose for this was for specifically wound healing applications. We produced it with our NS24 in the drum collector area. So let's move on to the next slide. Yeah, so as we said before, we exercised a R&D project with a customer from the United States, and we produced basically a PCL nanofiber scaffold for specifically wound dressing applications. So it's something we are well accustomed to. Let's move on to the next slide. Okay, yeah, so this is like more advanced applications that people are still trying to continue research on. So organ barrier, so when you have an open surgery, there's a problem with adhesion between specific tissues, and to do that, to prevent that, you would have to have nanofibers as organ barriers. Going further, dental implants and oral cavities. So nanofibers also help with the inhibition of the growth of oral pathogens. So something very, very useful for nanofibers that people are doing, and also eye treatment because of how similar it is. Let's move on to the next slide.
So right now we have given you detailed information about biomedical applications of nanofibers, and right now I just wanted to give you also details and information related to the market size of this sector. The healthcare and the biomedical segment actually dominate the market demand. As you can see from the table, since 2017, it's rapidly increasing, and due to the COVID-19, the growth rate will be more than 23%. So the healthcare and biomedical industry actually is the largest contributor to the growing demand for nanofiber globally. Also applications, as my colleague Ömer mentioned, such as drug delivery, wound healing, tissue engineering, and barrier textile. Actually, these services of nanofibers on a wide scale in healthcare and biomedical industry is highly demanded. Nanofiber layers actually produced by biopolymers such as chitosan, gelatin, collagen. All these, materials can also be used as wound healing, dressing, and of course for significant support of the wound healing process. And also the market actually has this demand. Of course, you can see that the growth rate is increasing rapidly. So we can move on to the next slide so we can give you another table. So here, as I have mentioned, we have a high demand in, of course, drug delivery, tissue engineering, medical textile. Along with that, due to the COVID-19, of course, filters and membranes are popular due to masks, of course, which we have to wear to protect ourselves. Therefore, filters and membranes are 47% high in the demand. Of course, you can see from the numbers in the table, since 2016, the market actually grows so much, and of course, other applications of nanofibers and biomedical industry is of course highly in demanded.
Right. So next to filtration, electrospun nanofibers, like perhaps the biggest market next to filtration, would be tissue engineering and biomedical science.
Exactly. We can go on. Yeah, so right now we just wanted to show you a couple of videos in order to, in order to allow you to understand about our, nozzles and about our machines and of course about the applications. While you're watching the videos, please comment or give us your questions in the chat section. At the end of our webinar, we will have a question part where we answer all of your questions. So do not hesitate to, type down your questions. We will be happy to answer them all. Now we will just watch multi-hybrid nozzle video.
So yeah, you can see here we have a specialized design nozzle to emit multi-jet electrospinning, so as to increase the production capacity. So this is for in terms of industrial applications. So when you need to produce nanofiber scaffolds, for such reasons you would want them in large quantities. So this is essentially for commercialization. You can see multiple jets being formed, and you have multiple nozzles that are coming out of anodes that are connected to high voltage supplies, and they're all being electrospun onto the substrate, and they're being collected on and depositing. So it's like a roll-to-roll system. So essentially, this is the multi-hybrid system that we have.
And it's allowing you to produce a continuous production. Yeah, we can go on.
Right. Another thing I wanted to get into is the coaxial nozzle. So I mentioned before, this coaxial nozzle is basically a specific device that we have for composite solutions. So I mentioned before, we talked about drug delivery. So in that situation, you would want certain drugs to be like, either you want them to be burst released, you want them to be released immediately, or you want to have a slow dispersal of them. So in which case you would need to have the proper composites. So for this coaxial system that you see here on the video, you're having a particular drug solution that's in the core, and in the shell you would have the polymeric solution that encapsulates it. And two different solutions can help basically help control the drug release mechanism, and also for the specific purposes of multiple solutions. It doesn't necessarily have to be the drug inside in the core. You could have two different biomedical polymers that could produce and like basically complement each other with the integrate composite material properties. So I think the video itself was really good. It was self-explanatory of how it works. So essentially, this is the coaxial system. So right. So yeah. So then the question arises: what kind of biomedical applications can we have with Benzo lab and scale machines? So like we mentioned before, the PCL, like the scaffolds that you can have, artificial blood vessel type of vascular grafts. Drug delivery systems would mean basically the nanofibers with the drugs spun onto them or into them, embedded. These are essentially what most of our previous clients have been working on with our lab scale machine.
Of course, we offer many machines regarding to lab scale units. We have advanced level and of course entry level lab scales. So right now we will show you a video of our advanced level machine NS24, and you will of course definitely achieve artificial blood vessel, and of course when you get coaxial nozzle you will have of course
right. So you see the metal rod, which is the anode, being connected. This is connected to the high voltage. You are inserting the hybrid nozzle. This is for non-aligned fibers. Like you can see the stationary plate being deposited here. This is the multiple the multiple nozzle rod that you're also connecting. It goes up to 12 for the NS24. Yeah, so this is all about specifically for what catered your application to. You can load the polymeric solution. You can see there are two syringe pumps for the purpose of multiple solutions, like if you would need to, like for the coaxial system, or otherwise you could just use one of them, or for composite materials, whichever you would prefer. The machine itself is it's all controlled via touchscreen HMI. You can see that you can cater the flow rate, the amount of volume we're putting in, the high voltage that you want to put, even the spinning distance. All of that can be controlled via the touchscreen here. So yeah, you can see that she just activated the pump, and she's setting the voltage, which the range you can see 0 to 40 kilovolts. And then she will activate it, and you will see some jet dispersals beginning. So right now she's using the drum collector And I think she's going to now activate the rotation so that you can have essentially you can have more aligned fibers. So she's setting up the RPM amount and the spinning distance. So yeah, as I mentioned earlier. So this is essentially the process of how it goes. So you can see in the screen there are actually 4 different collectors. That's the drum, that's the flat, and the shaft, of course. And yeah, but right now for this case in demonstration, you have the drum. You also see that there's a uniaxial motion for the drum. It's for homogeneity, excuse me, so that the nanofibers deposit evenly to ensure that. And also you can, like for more advanced setups, if you have certain polymers that can only behave well or electrospin well in a specific temperature or specific relative humidity percentage matrix, you can control that accordingly with the machine. This port right here is for gas shield electrospinning. It's when you want to incorporate gas into the chamber, from the chamber all the way to the nozzles here. So certain polymers, electrolytic polymers, for example, hyaluronic acid, they need to be spun well, and they need gas assistance, like the pressure from the gas to help push upwards. So it's something that's also possible with this machine.
Yeah.
So
this is pretty much.
Yeah, that's pretty much it. So let's see.
If you have any questions regarding our units or the application areas that you want to learn more, you can always reach out to us by email. Of course, you can just type down your questions, and we would love to answer all of your requests and inquiries. Right.
So yeah, so our main goal is essentially trying to advance this research space, this industry here.
Yeah.
Because I think it has a promising future. So not with regards to machine, but also with R&D services and trying to advance forward. These were our references for the slides that we've shown you, and thank you so much.
So we can jump into the question sections if we have. Till we see the question sections, we just want to, of course, give you ideas about our R&D services. If you have any inquiries or any project regarding biomedical applications of nanofibers, you can reach out to us via email. So it is sales@innovenso.com. So you can just reach out to us via email, and we can set up a meeting and discuss your requirements and your needs. So let's go and questions and answer part. So will be uploaded this video in the channel. Yes, definitely. After our webinar, we will save the link, and of course you can always reach out to the video and you can always watch it back. So can you give examples of electrospun implants currently on the market? So yeah, there's like several examples. There are a lot of type of material that you can use. For example, magnesium-based materials, they're a promising choice, right, as a degradable implant, targeted for temporary, orthopedic and cardiovascular applications. So that's just one example. They've been apparently in the market for a while. Let's move on to the next question. Do you have a copy of this presentation? I would like to do an in-depth market sizing, especially energy, medical application, and air filtration. Of course, definitely. I can just share with you the presentation, but of course you need to send me an email, and I will of course assist you further about your interest. Our emailing address is sales@innovenso.com. Right. So for the third question, for the multi-nozzle system, how to ensure every nozzle working simultaneously while clogging not happening? It's one of the baseline features of our hybrid nozzle. So you saw in the video, it's not a standard small, thin metal rod. It's essentially a conical shaped nozzle which has a reservoir-based design. So what that does is it allows, it prevents clogging by pushing out the multiple jets of streams. So our hybrid nozzles are designed to not just to basically maximize production, but to also prevent clogging. So we don't have this issue with the hybrid nozzle system. Yeah. Let's move on to the next question if there's.
Hi, is it possible to add mineral nanoparticles?
Actually, it is possible. If you are interested such an R&D service, please contact us. As I have mentioned, always you can reach out to us.
Right.
Any of your project or inquiries are welcome to discuss. So we can always discuss them.
It's basically a case-by-case scenario, like what type of particles and what's their nature, the application, the solution, a lot of factors.
Definitely, we are helping our customers according to their projects, of course, their needs, their requirements. Therefore, as I have mentioned, every case is different than each other, and we are actually going case by case and answering their, inquiries.
So let's wait for the next question.
Okay, we are just looking at your next question. Okay, so and in your next question, you have mentioned, let's say, what is the minimum size of liquid or non-liquid NPs to be mixed?
Okay, so what is the maximum size of liquids and non-liquid nanoparticles to be mixed efficiently? So again, this is dependent on the project. There's a lot of parameters. There's a lot of solutions that you should need to consider, and their behavior towards the high voltage. So there's no generic answer we can give you.
So in the other question, you have mentioned to get the quotation for the setup you have shown in electrospinning. Definitely, you can get the quotation of our advanced level machine NS24, but you need to send us an email, and our email address is sales@inovenso.com. So after you can see below, so you can just find it right down below. So you are always welcome. Send us an email. So we will of course definitely provide you the quotations.
So let's see if there are any other questions.
Also, along with our advanced level Nanospinner 24, we have other ANI series which can be helpful to, of course, different applications and different projects. So as I said, we are just going on case by case according to your needs. We suggest and we try our best to suggest you the right system. So just send us an email and we will guide you towards your needs. Let's go on to other question if you have. Okay.
Okay, any question?
Yeah. So we are just looking at, okay. The question is that in that case, how you control the flow rate of every nozzle to be the same?
It's the same. Okay, so the anode that you saw earlier is connected to either a syringe pump or a peristaltic pump, depending on the amount of solution you're going to use and the machine type. It's basically controlled via software, and the solution is basically fed into like you would have a rod which has all the solutions, all the nozzles, and you're basically exerting all of them and feeding it out. So it goes out of the orifice of the nozzle. So yeah, is there anything else about? Yeah, so it's actually an interesting question, controlling the flow rate. So syringe pump, you basically you'll type in the type of the rate that you want to feed the solution. So it depends on the solution parameters as well, the flow rate. It also depends on the viscosity and the nature of how it goes, but it's being fed into a pulse rate from sequential amount of time. So okay.
So the other question, let's see. So I am a researcher from Institute of Space Technology, Islamabad. And what is the cost of currently shown electrospinning setup? So actually our machinery has actually budget of, actually for every budget actually. Like to understand your needs and to understand your project first, please send us an email. Our email address is sales@inovenso.com. So after we receive your inquiry, we will provide you the quotation of of course, Nanospinner 24.
Depending on your application.
Yes,
so
exactly.
What you would require.
Okay, we're just waiting your other questions. And then we will, of course, answer them all. Of course, if you have detailed questions, you can always send us an email. We can also answer them from email. So we can go down. Yeah. Okay.
So another question here. Do you currently have antibacterial nanofibers? So in our systems, you can produce antibacterial nanofibers. So it just depends on what type of material they contain. So we've already produced them and we have experience. So if you're interested, you can contact us. But if you would like a generic, like for general info, nanofibers with like say metallic nanoparticles that have this property to denature these bacteria. They essentially are the antibacterial nanofibers. So when you have nanofibers with a composite mixture of like silver particles or gold particles, they essentially inhibit the growth of the bacteria and even viruses to some extent. So let's move on to the question.
Of course, if you have any more questions related to other application areas, like let's say filtration, because we have also given you information related to filtration, you can also ask them in the chat section below. We can, of course, answer them too. Because due to COVID-19, along with the biomedical applications, filtration is, of course, important. And as we have mentioned in our webinar, we have done many R&D services for our customers abroad, of course, from all around the world, along with, promoting our advanced level or entry level machines for wound healing applications, tissue engineering applications, and drug delivery applications. So, of course, according to your budget, your requirements, your project, we can always discuss further, and then we can just choose a right system, an appropriate system for your needs.
So there's another question here. Is it possible to add vitamins or hormones in nanofibers for drug delivery? So again, this depends on the type of material you're using, what nanoparticles, if they even have like ease of electrospinning together. But generally, it's possible. But if you require more information, please do contact us. And of course, please give some details about your project so that we can further advise you.
Because it's important for us to understand your requirements. We need to know what you are required for. What are your projects? What you're expecting for this production or this R&D service. Therefore, it's best if you contact us from email and we can all discuss further in detail. So let's see if we received any more questions.
So another question is, would it be able to control environmental parameters in the spinning chamber? So yes, absolutely. In like the machines that we showed you earlier, the NS24, and in the NE series generally, there are extra components that you can add, such as the temperature heater, the temperature controller, and the humidifier, which reduces the humidity. So you are able to affect the ambience of the chamber inside, and that, as a result, affects the nanofiber jets that are being formed. So it's certainly a possibility in our machines.
Not only the environmental parameters, such as like humidity, temperature, we have many additional options and modules that are actually waiting for you to add your machinery, such as like basic, camera integration. Of course, we have gas chamber, like other sort of additional modules that are available. And of course, it is easy to upgrade in the future with our NE series machines. So let's see if we have any
I also should mention that the dehumidifier, essentially, the range is like about from 90, 80 RH% all the way, it can go down to say 20, 30. And the heating range is about from all the way maximum to 40 degrees Celsius. So it's basically, scientifically speaking, what it does is it affects the kinetic energy of the solution, which may in fact help the nanofiber electrospinning process. So it's something that you should look into. Let's see if there's any other question. Have you tried balls as possible free surface electrospinning? No, we have not tried. Okay, let's see if there's.
Yes, we are waiting your another question.
Okay, so let's see if there's anything.
Mm-hmm. Okay.
Okay, so okay, there's one here. I meant in the multi-nozzle system how to ensure the flow rate of every nozzle to be same. So essentially, when you're pumping the solution, we are taking into account the flow rate of how much it's going into the tube or the rod. For the nozzle, for the flow rate, the instantaneous flow rate for each nozzle, you would have to basically extrude them from each of the orifice before starting the solution. So you would purge the solution all the way from the syringe or the peristatic pump, basically where the source of the solution is, all the way from the tube channel to the the nozzles. And once it starts coming out of the orifice, is when you start activating the once you start the pumping, basically the syringe pump or the peristatic pump, whatever it is. But essentially, standard deviation is the limit. So we are doing calculations and calibration for each standard deviation to ensure that there's even enough flow on each of the nozzle orifice. So yeah, I hope that answers it. Okay, is there anything else?
Okay, we are just waiting for another question. So let's see. Okay. So our new question.
Is there any? Hold on. No, not yet.
Okay.
Oh, okay. There's one. So when applying an electrostatic field to the multi-nozzles, the electrostatic field intensity of each nozzle is different, which will result in uneven fibers and uneven membranes. How to overcome this? Actually, that's a very good question. So it of course depends on the solution and how it behaves with the electrostatic field. And of course, when you have jets emitting out of the orifice, there's going to be some interference issue, which can cause further degradation of your nanofiber scaffold. So the way that we combat this is that you have to affect the solution parameters itself. So like, for example, the ionic properties, the conductivity, in certain cases, even the environmental change can overcome this issue of interference between electrospun jets, because each nozzle would have its own electrostatic field, of course, and then you would want them to be like, necessarily equidistant or enough equipotential so that they don't start mingling with each other. Mm-hmm. So we also have this like issue. So essentially, let's move on to the next question.
So if you would like to discuss this topic further with our scientists, actually we have many scientists working in Innovenso technology. Yeah. We have more than 12 years experience in this nanofiber field, and we can answer this question much more detailed.
Yeah, this question is actually it's very, very. I mean, you can see it's very focused. We need to actually sit down and like there's a long answer for that. So it's something that depends on what you're using and what type of material you're using. Excuse me, the hardware as well, and the nature of things. So, is there any other question?
No.
I see.
So, if you have any more questions, as we have previously mentioned, you can always send us from email. Our email address is sales@innovenso.com. So you can send your inquiries, your price quotation requests, along with your R&D project requests, and we can always guide you towards the right system or right project according to your needs, according to your budget, I believe you will see our email here, and then you can always contact us. I believe if we don't have any more questions, I think today we are done with our webinar. We thank you for your participants, and we are really thankful that you joined our webinar.
And we hope to see you for the next webinar.
Yes, we really hope to see you all again. So have a